Hello and welcome to Tech Decoder. Today we're diving into steganography, which is hiding messages inside images using MATLAB. In this video, we're covering 4 key segments. First, we'll start with a brief overview of steganography, where we'll discuss what it is and why it's important. Next, we'll walk through the embedding and extraction process, showing you how messages can be hidden and then retrieved from an image. After that, we'll delve into a live demo, putting our MATLAB tool to the test. And finally, we'll wrap up with the results and analysis of our methods, emphasizing the importance of choosing the right image file format. Stay with us as we uncover the fascinating world of steganography step by step. Steganography is a method for hiding information inside regular files like pictures, songs, or videos. It conceals messages so that they can't be detected without special knowledge. Only the right recipient can spot and understand the hidden information. This way, steganography helps keep communications confidential and adds a layer of security in today's world where digital privacy is essential. Moving on to the embedding and extraction process, we will break down the code that makes this fascinating process possible. Let's walk through the code to understand how each line plays a part in securing your data. First, the code asks users to type in the name of the image, where they want to hide their message. Next, it's crucial to make sure the image exists on your computer. If the code can't find the image, it'll let you know, so you can double-check the file name. Then, the user chooses which bit of the image's pixel data to use for the message. This can be any bit from 1 to 8, where 1 is the least significant bit and 8 is the most significant. Next, you'll input the secret message that you want to embed within the image. This message will be converted into a form that can be hidden within the image's data. The image file is then loaded by MATLAB, pulling all the pixel information into the workspace so the code can start the embedding process. Each character of your message is now turned into binary code, including spaces. This means your message is transformed into a string of zeros and ones. The length of your binary message is also converted into binary form. This helps to know how much space the message will take up in the image. Now, the binary data of your message and the binary representation of its length are combined. This single string contains all the info needed to hide, and later find the message in the image. This combined binary string is then converted into a vector, which is a series of numbers that the computer will use to embed the message into the image. The code checks to ensure the image is big enough to hide your message. If the image is too small, it will let you know. Here's where the magic happens. The binary vector, which represents your message, is carefully inserted bit by bit into the image's pixels at the position you chose. After the message is hidden within the image, the new version of the image is saved in several file formats, including PNG, JPEG, TIFF, and BMP. Finally, the modified image, with your hidden message inside, is displayed on the screen. To the untrained eye, it looks just like the original. Here's a summary of the steps of the embedding process. Our extraction begins by asking for the modified image file name. You'll type in the name of the image that holds the hidden message. The code then checks if this image actually exists on your system. If not, you'll get an alert to ensure you've got the right file name. Next, you specify the bit position where the message was embedded. This has to match the position used when hiding the message, and it can be any number from 1 to 8. Now, MATLAB will read the image you've chosen, preparing to search for the secret message within its pixel data. The first task in extraction is to figure out how long the message is. The code looks at the first 32 bits of the image to get the message length in binary, then converts it to a number we can use. With the message length known, the code calculates the total number of bits it needs to read from the image to get the whole message. Starting right after the message length, the code reads bit by bit to collect the entire binary sequence of the hidden message. Once all the message bits are collected, the code converts them from binary back to text. It takes each 8-bit chunk and changes it into the ASCII character it represents. In the final step, the code displays the extracted message. What was once hidden within the image is now revealed as plain text. Here's a summary of the steps of extraction process. Now that we've covered the basics and understood the code, let's move on to a live demo to see how this all works in action. Welcome back. On the screen, you see the MATLAB code we've discussed. It's designed to embed a secret message within an image without changing its visible appearance. Let's put it into action. As we run the code, it first asks for the image file name. We'll use image.png for this demonstration. Now it requests the bit position for embedding our message. We'll choose 4, striking a balance between robustness and imperceptibility. Lastly, we input our secret message, "Hello Kitty Mew Mew." Watch as the code processes our inputs. What's happening behind the scenes is that our message is being converted into binary and tucked away into the 4th bit of each pixel's data. Here's our image post-embedding. To the untrained eye, it looks identical to the original, but encoded within its pixels is our hidden message. As you can see, there's no difference between the original and modified image. Our secret message is well hidden. Having successfully embedded our message, let's move on to see how we can uncover it. On our screen is the MATLAB code for the extraction process, ready to reveal the hidden text within our image. Initiating the code, it first requests the name of the image with the embedded message. Now it needs the bit position we used to hide the message, which, if you remember, was 4. And there you have it. The code has successfully retrieved the message. This proves our approach is not just about hiding, but also about the ability to retrieve what has been hidden. Our MATLAB tool has been tested for embedding and extracting messages within images, showing it's an effective technique for steganography. It works by changing certain bits in the image to hide the message without being noticed. Consistent performance is achieved by using the least significant bits for embedding, ensuring the image looks the same and the message can be accurately extracted. The choice of image format is crucial. Lossless formats like PNG, BMP, and TIFF are the best because they keep every bit of the message intact. However, be cautious with lossy formats such as JPEG, as they might alter or lose the hidden message when the image is compressed. And that wraps up our demonstration. Thank you for watching. For more tech tips and tutorials, remember to subscribe and hit the notification bell. See you in the next video.